Okay, so we're going to go on to task 1. So make sure you're on Ed with me. So we are going to think about this problem before we even look at any of the answers. So Rosalind also needs to add 5/8 cups of orange juice to make a sauce for her stir fry. If she uses a 1/4 cup measuring cup, how many measuring cups will she need to add? So one thing I would like you to do is open up in your Ed. So come to your main page and go to your Discover tab and look for your digital toolbox. Yours might be in a different place on the page, but it's under the Discover tab. Go to your digital toolbox. Scroll down and find the fractions and open up your fraction toolbar. You guys always have these tools available to you. So I know that she has 5/8 of a cup. So I'm going to go ahead and add 5/8 here and line them up. So go ahead and do that on yours. Okay, so we both should have 5/8 here. Now she only has a 1/4 cup measuring spoon though. So, or cup there. So I'm going to say I can notice when she scoops out a 1/4, she's really getting 2/8 there. So if she scoops out another 1/4, she scooped up 2/8. If she scoops out another 1/4, she's only going to fill it up halfway. So these tools are here for you to use and think about whenever you need them. So let's come back to our problem here. So I know that she is scooping up 5/8 and she's using a 1/4 measuring cup. I can also think about that mathematically and turn my 1/4 into an equivalent fraction out of 8. So 4 goes into 8 2 times, so 1 times 2 is 2. So that means every time she's scooping out a 1/4, she's getting 2/8, which we proved over here as well. Every time she scooped out 1/4, that was 2/8. So using that information, we're going to go ahead and complete tasks A through D on number 1 here. So back to our task page. So we're going to turn 1/4 into that equivalent fraction of 2/8. So we can divide 5/8 into groups of, what are we wanting to do? 2/8, sorry. I got distracted there. So every time we scoop out a 1/4, we're really doing 2/8. So we're going to divide our 5/8 into groups of 2/8, 2/8, 2/8 as much as we can. So now we're going to use this number line and go ahead. And I notice it's cut into 1, 2, 3, 4, 5, 6, 7, 8 pieces. We've got 5/8. So go ahead and mark where 5/8 is. 1, 2, 3, 4, 5. So this is how much I have. So then using a different color, go ahead and circle groups of 4ths or 2/8 because those are equivalent. So circle or block off 2/8, 2/8, and see what is left over. Just keep going all the way through 2/8. So then that should help you picture how much orange juice, how many cups as she scoops out that she needs to add. And you also have that fraction picture here as well. So it looks like she needs to scoop out 1, 2, and a half here. Okay, so then D, if she only used a 1/8 measuring cup, so every time she did 1/8, and she still needs 5/8 of those, how many times will she have to scoop 1/8 out to get to 5/8? So if you need to use that fraction or draw yourself a picture, so she has 5/8, how many times will she have to scoop out 1/8? So first she had a 1/4, but then she found a 1/8. So what if she had a 3/8 measuring cup? How many times would she need to scoop that out? So think about your 5/8. block out 3/8 and see what's left over to see how many times she would have to use a 3/8 measuring cup. Okay, so we are going to fill in this chart of her results. So the first time she had 5/8, and we divided it into groups of 1/4. 5 divided by 1 is 5. 8 divided by 4 is 2. 2 goes into 5 2 times with 1/2 left over. 2.5, which is what we found up here. 5 divided by 1 is 5. 8 divided by 8 is 1. 5 divided by 1 is 5 whole times. So see if you can figure out this problem here and match it up. So I know the first one was 5, so it's got to be one of these two answers. So decide which one will this last part be here. Okay, so when I look at this problem, I noticed 5 divided by 3 does not work out very nicely. Kind of end up with a weird problem there. So I really like to use this strategy of using a reciprocal. So let's take a closer look at reciprocals here. So two numbers whose product is 1 are reciprocals. You might also hear it called the multiplicative inverse, and you'll see why we call it multiplicative in just a second. So reciprocal means opposite. So the opposite of 3/4 is to make it 4/3. I just flipped this fraction upside down. And I need to make it be a product, which means I multiply. So when I multiply here, let's see what happens. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. So the answer is 1. The answer to a multiplication problem is 1. So when you multiply something by its opposite, you get 1. So let's try this 5/8 here. So what's the reciprocal of 5/8? Is 8/5. And we're going to multiply. So I'm going to show you a little trick here. We can simplify going across as long as you have a numerator and a denominator. I see 5 and 5 are the same. 5 divided by 5 is 1 and 1. And 8 divided by 8 is 1 and 1. So we're just making our work a little easier here. 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1, 1. So let's take a look at when we would use this. So some of those problems when we were dividing worked out great. 5 divided by 1 is 5. 8 divided by 8 is 1. 5 divided by 1, 5. And everything worked out perfect. They were all nice whole numbers when we divided. 3 divided by 9, though, is 3/9 or 1/3. That didn't end up in a nice whole number. 8 divided by 4 is 2, but I can't have 1/3 over 2. I can't have a fraction on top of a fraction. That just doesn't work. So that's where our multiplicative inverse or the reciprocal is going to come in handy. So we take our dividend, what we have. So I have 3/8 and we copy that one. That's what I have and I keep it the same. I'm not changing that. But we're going to multiply by the reciprocal. So instead of dividing, I'm doing the opposite of divide, which is multiply. There's my dot. And then I'm doing the reciprocal. Since I changed to the opposite of division, I have to change to the opposite fraction, which turns into 4/9. Now, if I look here, I can simplify. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. I also noticed that 4 and 8 are divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So I end up with 1 times 1 is 1, 2 times 3 is 6. So if I have 3/8 and I need to cut it up into 9/4, each part would be 1/6. So I can do that without simplifying first. It just makes a little more work. So 3 times 4 is 12. 8 times 9 is 72. And then I'd have to simplify, which turns into 1/6. So I like to do my simplifying first, so I'm not working with such big numbers. So let's go ahead and try parts E through D on task 1. So remember, we're going to copy the first one, keep it the same, change it to multiply, and flop and use the reciprocal of that second fraction. So let's take a look here. So first, see if you can find the reciprocals of each of those numbers. So flip them upside down. Okay, now we're going to use that copy.flop strategy there to find our products. So we had 1/4 here, so we need to flip that upside down. So it'd be 4/1. So see if you can finish and flip all of these fractions, and in order, tell me what each of the new numerators would be there. So filling in these question marks in a row. Okay, so then you're telling me this strategy. So using that copy.flop method, so multiply the first fraction by the reciprocal of the second. So keep the first one, copy it, multiply, and flop. In each row of the table, the quotient is less than, is greater than, is equal to the, let's see, so the quotient here is the answer to a division problem, and we're comparing it to the product, 5/2, 5/2, 5, 5. So it looks like either way we do the problem, we end up with equal answers here. So in each row of the table, the quotient is equal to the product. So whether we divide or times by the reciprocal, that's the same process. We're getting the same answer.